Okay, so today we'll be studying the mole concept. What do we mean by the mole concept? We are looking at a scientific number that is used to determine the number of moles we have or the number of entities we have in a particular amount of a substance. Okay, so when you say the mole concept, it can be defined as the mole concept can be defined as the moles in the amount of substance which contains as many elementary particles as there are in 12 grams of carbon. So like we studied before, when we say carbon is roughly considered as the most abundant or the most common element we have on this planet, and as such most other elements are measured with respect or in relation to carbon. In the same way, 1 gram, 12 grams of carbon 12 is said to be equal to 1 mole. So when we say 1 mole of any substance, it means that it has the same particles as 12 grams of a substance. So 12 grams of carbon is actually 1 mole. All right. Now, when we measure them, it is believed that 1 mole of any substance is made up of 6 times or 6.02 times 10 raised to the power 23 particles. Okay, and that is what we refer to as Avogadro's constant. So when we are asked that, what is the meaning of Avogadro's constant? We say it is the number of elementary particles in 1 mole of any. So in other words, Avogadro's constant is the amount of particles we have in 1 mole of any substance, and that number is 6.02 times 10 raised to the power 23. So in other words, if we are asked that how many particles are in 12 grams of carbon, we know that 12 grams of carbon is equal to 1 mole, and as such it has 6.02 times 10 raised to the power 23 particles. Okay, so that is what we mean by Avogadro's constant, and it is the unit we use to compare the number of particles we have in all substances, whether those substances are atoms, molecules, ions, electrons, or compounds, or whatever they are. Okay, so anytime you are told that you are supposed to find a number of particles in 1 mole of atoms, that is to tell us that 1 mole of atom has this number of particles. In the same way, 1 mole of molecules also have the same number of particles, 1 mole of ion, 1 mole of electrons, and 1 formula unit of any compound has the same number of particles. Okay, so it doesn't matter of what is being asked of. So far as they are asking for 1 mole of it, it means that it has 6.02 times 10 raised to the power 23 particles. Okay, that is what it means. Whether it is an atom, a compound, a mixture, whatever it is you are being asked of, 1 mole of it has the same number, 6.02 times 10 raised to the power 23 particles. Now we'll move on to the concept of molar mass. When we say molar mass, as you can see here, we have grams per mole. So we are saying that molar mass is how many grams do you have in 1 mole of a substance. That is, what is the mass of 1 mole of a substance. The definition is molar mass is the mass of 1 mole of any substance. That is what we refer to as what? Molar mass. The mass of 1 mole of a substance. Now the various elements on the periodic table have their respective mass. Okay, if you should look on any periodic table, like we can see here, there are various elements. The values we are seeing here are the atomic numbers, and what we see here, okay, in this case 44.95591 is what we refer to as the mass of scandium. If we come to calcium, the atomic number is 20, the mass number is 40.08. So it goes on. Carbon, As we can see here, the atomic number is 6, the mass number is 12.011. So the molar mass for carbon is 12 grams. It has the same number of particles as the molar mass of cobalt, okay, which is 59 grams, but the same number of particles, and the molar mass of sodium is 23 grams. Okay, so that is telling us that 1 mole of carbon is 12 grams, 1 mole of cobalt is 59 grams, 1 mole of sodium is 23 grams. At the end of the day, they have the same number of particles, but because their mass is different, their weight is also going to be different. For instance, metals are heavier than wood. Okay, so they may have the same number of particles, but it does not mean that their weight would be the same. It also doesn't mean that their mass will be the same, because one item has more mass than the other, just like we saw on the periodic table, and just as it has been noted here. So they have the same number of particles. So if we pick carbon and we pick 6.02 times 10 raised to the power 23 particles of carbon, they are going to have a mass of 12 grams. Cobalt, same particles, will also have a mass of 59 grams. Sodium, same number of particles, will have a mass of what? 23 grams. So you can check the mass of all other elements on the periodic table. Okay, do your best and familiarize yourself with them. You are not supposed to memorize them, okay? But at least if you know a few of them, it's quite good. Now let's move on to formula mass. When we say formula mass, we are looking at molecules and compounds. Okay, so 1 mole of a particular compound or molecule, okay, will have its own mass, which we refer to as formula mass. So formula mass is the mass of 1 mole of the formula unit of a substance. Okay, for instance, we have tetraoxosulfate, 6 acid. Again, we have tetraoxosulfate, 6 acid. Okay, where so hydrogen has its molar mass to be 1, sodium 32, and oxygen is 16. But if we look at what we have here, there are different number of atoms. Okay, so for hydrogen, we have 2 atoms of hydrogen. So that will give us 2 times 1. So that would give us 2 times 1. And then we have only 1 sulfur atom here, and that would give us 32. Oxygen is 16. But then we have 4 atoms of oxygen, so that would give us times 4. If we are to work this out, we are going to have 2 plus 32 plus 64, and all of that is going to give us 96. Oh, sorry, 98 grams. Okay, so this is the molar mass of tetraoxosulfate 6 acid. Alright, so we could also try again for we could also try that for calcium trioxocarbonate acid, and then the unit mass for each atom has been given. Okay, so we have 40 grams for calcium. Calcium has its mass to be 40. Carbon is 12. And then oxygen is 16, but we have 3 units of oxygen, so we have to multiply the 16 by 3, and that is going to give 40 plus 12 plus 48, and in total that would be 100 grams. Okay, so the molar mass of calcium trioxocarbonate is 100 grams. That is, given 1 mole of that, the mass is going to be 100 grams. So 1 mole of calcium trioxocarbonate is 100 grams. Okay, so we have to find the molar mass for the 2-trioxonitrate 5. Lead has 8 unit mass to be 207, nitrogen is 14 and oxygen is 16. But again, we only have 1 lead, but then we have 2 nitrogen, and then we have 6 oxygen. Okay, keep in mind that we have 3 here, and then we have 2 of it here. So 3 times 2 would give us 6. We have 1 nitrogen here. 1 times 2 would give us 2. So this 2 is for only the values we have in this bracket. Okay, so that is going to give us 207 plus 28 plus 76. When we sum all of these up, we are going to do 291 grams. So the formula mass for lead trioxonitrate 5 is 291 grams. Okay, I think I made some mistake here. Let me correct myself. And let's see. So this would give us 28, and 16 times 6 would give us, I think this is supposed to be 96. Okay. So going on, when we sum everything up, our answer would be 331 grams. So from what we have done so far, 1 mole of tetraoxosulfate 4-acid is going to give us 98 grams. 1 mole of calcium trioxocarbonate 4-acid is going to give us 100 grams. And 1 mole of lead 2-trioxocarbonate 5 is going to give us 331 grams. That is what it means. Okay, so 1 mole of the compound we have here, that is lead 2-trioxocarbonate 5, is going to give us 331 grams. I hope we are grasping everything. Now let's look at how we can calculate the number of moles in a given substance. Okay, so the number of moles in a given substance is equal to the mass of that substance divided by the molar mass. So what does this mean? If I want to know the number of moles I have in a substance, I would need to know the mass of the substance I have and divide it by what? The molar mass. Because the molar mass is 1 mole. Like we have done here, this is the molar mass of this compound. And this molar mass is 1 mole. So if I should say I have 700 grams of this substance, dividing it by 331 grams will tell me the number of moles I have in 700 grams, which will roughly be 2 points, a number I'm yet to work for. Okay, so the molar mass of a substance will divide the given mass of that substance to give us the number of moles we have on it. I hope it's understood. So the formula can be given as N. N stands for the number of moles of that substance, and M here is standing in for the mass of that substance, usually given in grams, and then the capital M here, or the large M here, we see dividing the mass is what? The molar mass. So number of moles is equal to mass, which is in grams, divided by the molar mass. So grams will cancel the grams and then we'll be left with moles. I hope it's understood. We've said that the molar mass is calculated in what? Grams per mole. Okay. So rewriting that is going to give us grams per mole all over grams per mole. Okay. When we cancel them out, we will end up having what? Only mole. So that is that. So let's work out this example and see. Find the number of moles in 11 grams of carbon. First, we need to find the molar mass of carbon. So the mass of this is carbon dioxide. The mass of carbon is 12. That of oxygen is 16. Multiply that by 2, and that is going to give us 12 plus 32, which will be equal to 46 grams. 46 grams per mole. Okay, so now the number of moles is equal to the mass over the molar mass. The mass we have here, we were given 11 grams all over 46, and that is going to give us, oh, I keep making mistakes. So I just recalled here that 12 plus 32 is supposed to give us 44. So we are going to have 11 divided by 44, and that would give us 0.25 moles. Yeah. So that's the number of moles we have in 11 grams, 0.25 moles. Now let's take another example before we move on to our next subtopic. Now, how do we calculate the amount of mass or grams in a given mole of a substance? Okay, we can use the same formula and then we do change of substance. So we learned that number of moles is equal to the moles of the substance divided by what? The molar mass. So if we should multiply both sides by the molar mass, we'll end up having what? The mass. So the mass, which is the amount of mass of a substance, is equal to the number of moles times the molar mass. Number of moles times the molar mass would give us the mass. But let's keep in mind that most of this, sometimes it is not given straight away, so we'll have to work around it. So what is the mass of 12 moles of ethanol? We are supposed to find the mass of 12 moles of ethanol. So we are looking for the mass of how many moles? 12 moles of ethanol. This is the formula for ethanol. Now we need to find the formula mass or the molar mass for ethanol. So carbon is 12, where we have 2 carbon atoms. Hydrogen is 1, but then we have 6 hydrogen atoms. There is 5 here, and then there is another one here. So that would give us 6. Then we have 1 oxygen atom, which is 16. So when we sum all of these up, this is going to give us 12 times, we would have 24 plus 6 plus 16. So we would have 12 times, yes, 46. 46 times 12 would give us 46 times 12 is going to give us that would give us 552. But in the question also, when I realized we were supposed to find 2 moles, so instead of 12 we are supposed to have 2 times 46, and that is going to give us 92. Okay, so that is 92 grams. This is 552 grams. So in case you were wondering why I use 12 I don't have my glasses, so probably that's where the oversight is coming from. Okay, but we're actually asked to find 2 moles of ethanol, so that would be 2 times the molar mass. The molar mass is 46, which we correctly found here, so 2 times 46 will give us 92. But then if we were to find 12 moles, okay, that would be 12 times the molar mass, and that would be 12 times 46, which would give us 552. Now let's move on to how we can calculate the particles in the mass of a substance. So how do we know the number of particles we have in a substance? Okay, so the number of particles, that is, this is N with a subscript of capital A, which stands for Avogadro's number, will be equal to the mass divided by the molar mass. Okay, and remember that this is going to give us what? The number of moles. So in other words, it is number of moles times Avogadro's constant. Okay, number of moles times Avogadro's constant. I hope you know why we need the number of moles, because 1 mole is going to give us this exact number, but we need to know the number. So if we have 11 grams, we have to divide that 11 grams by its molar mass. Then we know the number of moles we have there before we multiply by this. And our understanding of scientific notations, standard numbers, multiplication of standard numbers, will have to come in here. So in working for this, the number of moles would be equal to mass over the molar mass times 6.02 times 10 raised to the power 23. Now we've been asked to find the number of atoms in 50 grams of sulfur. Okay, we know that the formula mass for sulfur, the unit mass for sulfur, is 32. So we have 50 grams of it. The molar mass we are using here is 32. Okay, and we are multiplying that by the Avogadro's constant. So that is going to give us, that is working from our calculator, we are going to have, so this is what we have as our answer, 9.460. So let's write that down. So this is going to be the number of particles we have in the substance.